Welcome to section 4.5. We're going to be solving quadratic equations, only instead of solving them like we did in Algebra 1, where we allowed you to have a decimal answer, the stuff that we're going to be doing today will not have decimal answers. We'll be dealing with square roots, okay? So here's what happens. When you have a positive number, there are two square roots. One is a positive square root, and we're going to just call it the square root of s. One is this negative square root of s, because when you square root something, you get two possible answers, okay? So the principal square root is what we call a positive. If they don't ask for both solutions, okay, if you are not solving, then you can just use the positive square root. If you're trying to solve an equation, though, then you actually have to have both, okay? Now, a square root or a radical is another word for it. Looks like this, okay? Now, the only thing is, we don't actually, when we think of square root, it's the opposite of a square. And so normally what people think is there should be a little 2 with a square root, okay? Now, I will never write that 2 in, but this is kind of as we're going. Now, some people also kind of put this extra little line in there, and they do that because we're going to actually long divide in chapters coming up, and that will kind of help with some of that confusion, okay? Now, there are two properties. What it says is if I have a square root times a square root, I can just multiply the numbers inside and then take the square root. Or if I have a square root divided by a square root, I can just divide the two numbers and then take the square root. We're going to use those kind of as we go through just to ensure that we're on the right track. Now, when you're looking at a radicand, okay, which is basically just the number below the square root, so the number beneath it if we go back above, you don't want to use 1, which is the perfect squares. You want to look at something other than 1, because breaking down into 1 won't change the answer. There is no radical sign in the denominator of a fraction. And I'm going to show you a couple of them, and then there are some things that we're going to skip this year that we will do in pre-calc if you're thinking about moving on to pre-calc. But just kind of keep in mind that I am going to skip some of the stuff that's on here. Okay? Now, our goal is to break the square roots up again into the perfect squares like we did for factoring. So let me go through those one more time. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. That's through 12. And again, you could go higher if you needed. But we're looking for these numbers to divide square roots out, okay? So let's look at 75. If I look at 75, here's what I do. I start at the one right below it. So I start at 64. And I say, can 75 be divided by 64 evenly? The answer is no. So I do it again. 75 divided by 49, you get a decimal, so I don't want it. 75 divided by 36, you get another decimal, don't want it. 75 divided by 25 is 3. So what I'm going to say is this is the square root of 25 times the square root of 3. Because I'm basically taking this product property rule and working it backwards. The reason I picked this combination is because the square root of 25 is 5. The square root of 3 I can't do anything with because I get a decimal, so I leave it as the square root of 3. And my answer for the square root of 75 is the same thing as 5 square roots of 3. Okay, let's try another one. 98. So I start at 81. 98 divided by 81, I get a decimal. 98 divided by 64, I get a decimal. 98 divided by 49 is 2. So I'm going to break this apart as the square root of 49 times the square root of 2. The square root of 49 is 7, so you're left with 7 square roots of 2. Okay, last one in this little top section. I can square root both the top and the bottom, and I want to try and break these apart. Now, I know we said right up here you can never have the square root in a denominator. But here's what's nice. The square root of 100 is 10. and the square root of 169 is 13. This is not reducible, so I leave my answer right here. If you can't do that, I am going to show you an alternative method, but this is the idea so far. This should be a review of some of the geometry stuff that you did, hopefully. We're just trying to get you back into that. Okay, now let's take a look at this. Can I break down 7 with my perfect squares? Well, no, because 4 doesn't go into it. Okay, 35 is 7 times 5, so that doesn't work either. Okay, so here's what I'm going to do. I'm going to multiply 7 times 35 together, and I get the square root of 245. And now I start taking 245 and I start dividing it out. Can you divide by 121? Can you divide by 144? Can you divide by 81 or 64? And you just keep going down. What I end up finding is that the square root of 245 is the square root of 49 times the square root of 5. Well, the square root of 49 is just 7, so 7 square roots of 5 is my answer. Okay? Now let's do the same type of thing. Here's what I can do. The square root of 8 can break down. And so what I'm going to do is I'm going to multiply the numbers in front first, and I have this 12, and then I have times the square root of 8 times the square root of 28. Now the square root of 8 breaks down to the square root of 4 times the square root of 2. And 28 is 7 times 4, so the square root of 4 times the square root of 7. The square root of 4 is just 2, and the square root of 4 here is just 2. The square root of 2 and the square root of 7 I can't do anything with. So here's what I'm going to do. All of the big numbers I'm just going to multiply together. So 12 times 2 is 24, times 2 is 48. And the square root of 2 times the square root of 7 is the square root of 14. And there's my answer. Now, there are many, many ways to do that. That's just one of them. So if you're looking at that going, I'm not so sure about that, ask in class, we'll do it again. Okay? Now let me do the last one. The square root of 6 cannot be broken down. So since I can't break it down, I'm going to multiply these two to get 3 times the square root of 36, since 6 times 6 is 36. Okay? Then, I know that the square root of 36 is 6, so 3 times 6 equals 18. Okay? One thing to keep in mind as you're going through is that if I multiply the square root of one number times the square root of itself, what ends up happening is a times a is a squared, so I square root a squared, and the square root cancels the square, and I just get a. Okay? Keep that in mind. That's a huge property that we have going through. Now, I'm going to actually cross off, as I look at this, B, C, and D, because those are things that we are going to skip. If you're interested in knowing it just for future reference, those of you that are thinking pre-calc, go through it, use your book. It's easy enough to figure out. Okay? But here's the big thing. I said we couldn't have a denominator we could not have a square root in the denominator of a fraction. So if we have the square root of b down below, we're going to multiply by that square root on top and bottom in order to clear out the fraction. And I'm going to show you what I mean. So turn the page. All right, I'm going to look at examples 1 and 2 with you. And then 3, I want you to go ahead and cross off because we are skipping this one. Okay? So here we go. Take a look at number 1. The first thing we want to do is break up the square root. So we're going to write it as the square root of 2 over the square root of 15. Now 15 cannot be broken down with our perfect squares. Since I cannot break it down, what I'm going to do, because I don't want a square root in the denominator, is I'm going to multiply by my square root on top and bottom. So the square root of 15 I multiply. Here's what happens. The square root of 2 times the square root of 15 is the square root of 30. So I multiplied these two. The square root of 15 times the square root of 15 is the square root of 225, which if I reduce that, you get the square root of 30 over 15. This then is our final answer, because as long as I don't have a square root in the bottom, then I don't have to do anything more with my answer. Okay, if you look at the decimal for the original and this one, you'll find the decimals are the same. So let's try one more. Here's the thing, before I do any simplification, I want to break apart the square root of 60. The square root of 60 can be broken down into, and I'm going to put this up top, the square root of 4 times the square root of 15. So I'm going to rewrite this a second. I have 15 divided by, square root of 4 is 2, and then the square root of 15. And it's always better to simplify the square root up front, and then you don't have to do a lot of reducing at the end. Okay? So here's what happens. I still have a square root on the denominator, so I'm going to multiply top and bottom only by the square root. 15 times the square root of 15 is just 15 times the square root of 15. I cannot combine those because I don't have, they're not both in a square root. On the bottom, I have 2 times, and we just found out that the square root of 15 times the square root of 15 is just 15. Now take a look. I have a 15 on top and a 15 on bottom. I can cancel those. So what I have then is the square root of 15 over 2. Okay? And so this is kind of the main idea as we're going through. You cannot have a square root in the denominator. Okay? So I'm going to move on a little bit to solving some quadratics. And actually, while I'm looking at this, we're going to skip our last example here too. And we can do story problems in class if I feel that it's appropriate before we get to the test. Okay? Now what we're going to do in the middle section here is we're going to solve equations. Now our goal is to get the x by itself. So I'm going to treat it as if it were a single x for a little bit just to kind of get the idea. And so according to PEMDAS, I do PEMDAS backwards, remember? So let me do it this way. M and D first. I'm sorry, let's try that over. PEMDAS backwards says A and S first, M and D second. Third is then exponents, and then fourth is parentheses. And we're going to use this as we go through to help us solve. So I'm going to get rid of my addition and subtraction first. So I have 2x squared equals 65 plus 15 is 80. So I did addition and subtraction. Now I'm going to get rid of the multiplication. So multiplying by 2 means to get rid of it, I divide by 2. So I have x squared equals 40. Now I do the exponent. To get rid of a squared, I'm going to square root on both sides. Now we said when you solve a square root, you should get 2 answers, the plus and the minus. Here's the problem though, 40 is one of those perfect squares that you can break down with 4 times 10, and the square root of 4 is just 2. So I'm going to rewrite this as 2 square roots of 10. So I really have 2 solutions.